Okay, very well.
All right, do you need to do a roll call, Bob, or we got everybody pretty much? Bruce is the only one not here.
Yeah.
Let's do, can I get a motion on the, everybody had a chance to look at the minutes last meeting?
Yeah, I did. I move we accept.
Give me a second, Rich. You're muted. Rich, are you on mute? He says he's not on mute.
It says mute here.
Can you unmute him?
I can't, let me see. No, he's got a, I can't unmute him.
Huh. You can hear us, Rich. You just can't, we can't hear you.
Jeez.
That's weird.
You could always use the chat too, to say something in the chat.
Just
Right.
to type something?
Right.
Okay. I wonder if it, Rich, I wonder if he got out and came back in with that.
Rich, when you joined, did you click with, it says join with computer audio. Did you click that?
Oops, he's going to come back. Sorry for the technical difficulties, Jonathan.
That's all right. It's typical.
Yeah, these days it's pretty
For
common.
sure.
We had to get used to this medium pretty quickly last year. So, I mean,
Yeah.
even last March, I was learning how to do this to get students from different places into our lectures. Oh, I think he's connected now.
Still can't hear you, Rich. Is your microphone on in the computer?
The volume up.
Oh, jeez. Well, I'll second the motion on the minutes and we'll just, everybody vote in favor of the minutes? Or both minutes? Okay, Rich is good. So we accepted the minutes. Rich, we'll just go ahead with Jonathan and then you could either call with questions, like call me or call Larry if you have any questions and we can do it that way.
Or
So-
the chat.
Or the chat, yeah.
Or the chat, right.
Schaefer's coming in. Looks like Schaefer's coming in.
Oh, here he comes. Okay. And Bruce is here. Bruce, you there?
Connecting to audio.
Bruce?
Yep, can you hear me?
Yep, we got you.
Okay, great. All right, thanks.
So we just voted on the minutes, accepted the minutes, and
Okay.
I'm going to
You
turn.
know, I was gonna vote yes.
All right. Yeah, we knew that.
Yeah, okay, all right.
So Jonathan's here with us, and we're just going to go ahead and turn it over to him. Jonathan, we've had some discussions. I guess Bruce talked to you briefly about your investigation into the pyrrhotite levels in foundations that you've been doing, and we'd like to learn more about that. It's our understanding you've got some assessment of at what level it's a problem and what level it isn't, if I'm accurate, but we'd love to learn more about what you've been finding.
Yeah, sure. I guess I can like share some slides and stuff if that would be helpful, because there's some imagery there, and I can get right to the risk analysis stuff, or I can also talk a little bit about, I don't know how familiar everybody is with exactly what we do and how we do it.
I don't think we're very familiar. So if we get a little background, that would be helpful.
So I think let's see, can I share my screen? Looks like
Hey,
it
Bill,
can.
before we get started, are we able to record this, Bill?
Bob is recording it.
I'm recording.
Okay, excellent. And you'll be able to share that with us later, maybe?
Yeah, it'll be posted on our website shortly also.
Okay, great, thanks.
All right, you're welcome.
And can Jonathan share screens, Bob? Has he got that ability?
I think I can.
Yeah,
I just need to pull up the correct presentation here.
He's a panelist. He's got the same link we have, so
Okay.
should, Jonathan.
Yeah, all right, just give me a second here. All right, let's go.
Hey, Rich, we heard you.
Okay, I changed my this speaker to my system, and I guess it's working now.
Yeah.
It is working.
There you
Great.
go.
Okay.
Got it.
All right, so this is actually a part of a presentation that I gave just a couple weeks ago to on a webinar that we did through the college, and actually the full webinar was with myself and my colleague Christoph Geis, who is my my cohort in this project. But this will be the abridged version. I'm sure you're all familiar with the towns that are afflicted. This is from the CROG map. It's a little 2018 is a little dated, but these are primarily the towns that we've been testing from homeowners that have requested a test from us. We have done several in Massachusetts as well, in the south central Massachusetts area, just over the border from these neighboring towns that are afflicted. We've also done some testing along the shoreline. We've been involved with an inspector that's working with a relocation company that is every time that they sell a home for someone relocating into Connecticut, no matter where it is, they want us to test it, which has actually been quite interesting because we've come up with traces amount of pyrrhotite in other places, which isn't a surprise to us, but people think that all of a sudden that if they have a trace amount of pyrrhotite that somehow their material came from Becker Quarry, which is definitely not the case.
Right.
And you're all, I assume, familiar with Becker's Quarry and where it's located in Wellington. We've got the geologic map of pyrrhotite bearing rocks and other sulfur bearing rocks behind it. And so these rocks actually extend all the way up through central Massachusetts and even up through the Connecticut Valley, but there is quite the hotspot of sulfur-rich rocks in eastern Connecticut, and is probably why this has been a perfect storm of a quarry that was accessing material in rocks that had higher than desirable levels of pyrrhotite. I'm a geologist, so I like showing pictures of rocks. This is what a piece of pyrrhotite in its raw form actually looks like. They tend to be not this spectacular in aggregate. And just briefly, the actual reaction that is happening with pyrrhotite is a oxidation of pyrrhotite that reacts and forms other minerals. And the issue is that those other minerals are larger in volume. And so the cracking is the result of this reaction where pyrrhotite breaks down, forms a sulfuric acid that then quickly connects with other sulfates, mainly gypsum, and then forms these other secondary minerals that are larger, and that's why the cracking happens internally from within. And so the structural loss in concrete is due to this pushing from the inward out of the new minerals that are being formed. So when we test for pyrrhotite at Trinity, we are doing two independent tests. We do and so we've not created anything new here. These are actually well-known analyses that have been used for quite a long time. And we just so happen, because Christoph Geis, my colleague, is a rock magnetist, have, I think, the best instrumentation for being able to measure the presence of pyrrhotite, because pyrrhotite is a magnetic mineral. And to very, very small quantities, sometimes annoyingly small quantities, we can detect the presence of pyrrhotite in concrete samples, in aggregate samples. And then we also can directly measure the total amount of sulfur, which is important because pyrrhotite is an iron sulfide mineral. And often when elevated sulfur levels are found, pyrrhotite is also associated with that. There are other sulfur minerals in rocks inherently, which makes it a little tricky. You can't really do sulfur alone. Certainly when we get, and you'll see sort of our results, when values are really high for sulfur, it's quite obvious that there are problems in concrete. We can see the map cracking, and pyrrhotite is also found in high concentrations using the magnetics. At low concentrations, however, sulfur can be a little tricky by itself because there are other sulfur minerals that are not reactive. And so being able to tease those apart, you need something else to be able to confirm the presence of pyrrhotite. And that's where the thermomagnetics come in. So I'm going to explain the thermomagnetic process because I think that's really important. But to start off first, it's important to understand that pyrrhotite is not a simple mineral. It actually has several different forms. I'm not going to get into the chemistry. Just know that there are some forms of pyrrhotite that are actually anti-ferromagnetic, but just for this purposes, just think of non-magnetic. And then there's a variety of pyrrhotite, the monoclinic variety, that is magnetic. And this has this, the reason why pyrrhotite is magnetic is because, and again, I'm not going to spend too much time on the sort of crystal structure of pyrrhotite, but the reason why it's magnetic is because there are these vacant spaces within the crystal, these open, clear circles. So this is just a model diagram of what this looks like, pyrrhotite at the atomic level. And when you remove iron from the crystal, because there's a mismatch of ions, there then becomes a magnetization of the mineral. And so there's a weak magnetization of pyrrhotite due to loss of iron within the crystal. And that is the property by which we can exploit to be able to determine whether or not pyrrhotite is in an aggregate or concrete sample. So the way we do this, and the way the magnetic susceptibility measurement works, is that the magnetic susceptibility instrument heats up a sample all the way up to 700 degrees Celsius. And this first result is, and it shows magnetic susceptibility on the y-axis and temperature on the x-axis. And this is a clean sample. We picked it up at Home Depot, a commercially available quick-read concrete. It's already got aggregate in it. And we wanted to just see what sort of a baseline concrete looks like from probably somewhere else. As the temperature heats up the sample, there can be things that happen at certain temperatures, which I'll get to in a minute for pyrrhotite. But essentially at about 600 degrees Celsius, the thermal energy becomes too much for the magnetism. And you can think about a magnetic piece of material with all these little compass needles that are aligned a certain way. It gets too hot, and all of a sudden the magnetism, the little compass needles are spinning all over the place, and there is no well-defined magnetism. And so the magnetism just drops off to nothing. So, you know, the material is magnetic. Even commercially available quick-read is slightly magnetic, and that's mainly due to the mineral magnetite that is in just about all rocks. And you heat it up to about 600 degrees and you lose magnetism. However, in a pyrrhotite sample, pyrrhotite has a different temperature that it loses its magnetism. So this is called the Curie temperature. And the Curie temperature of all magnetic minerals is known and is predictable. So at about 300 degrees Celsius, pyrrhotite loses its magnetism. And so as the sample is heated up past this point, if there's pyrrhotite in a sample, you get this little increase of magnetism, and that's due to the fact that some of those different varieties of pyrrhotite are rearranging themselves into the most magnetic form, into that monoclinic form. And then there's a loss in magnetism where pyrrhotite loses its magnetism. And then as it heats up more, they convert to magnetite. And once you get to 600 degrees again, it loses everything. So this little heartbeat blip, if you will, at 300 degrees is diagnostic for pyrrhotite. And the size or drop of this loss is proportional to how much pyrrhotite is in the sample. And so for all the samples we measure, Christoph is able to, quantify the top of this peak, the bottom of this peak, and this magnetic susceptibility loss for pyrrhotite is directly proportional to how much pyrrhotite is in a sample. And we tested this by taking some, so this is just a blow up of the actual curve and showing these sort of different parts of the pyrrhotite magnetic susceptibility loss, where certain phases of pyrrhotite change into the magnetic variety, and then the total drop occurs right there. And so there's some different things going on in this part of the curve that we're looking at too, to look at the various phases of pyrrhotite in different samples to see if that matters too. But we were able to test whether or not this sort of drop in magnetic susceptibility was something we could use going forward by spiking clean concrete, quick-rete concrete with known amounts of pyrrhotite. So as the known amount of pyrrhotite increases by our spiked samples, and we actually ordered some pyrrhotite from, I got it right here, from Galax, Virginia, which is just from Word Scientific, where we can get samples from, order up a piece of pyrrhotite. It's not Connecticut pyrrhotite, which matters because of the slightly different variations of the different mineral phases within pyrrhotite. This isn't a perfect way to know how much pyrrhotite is in a Connecticut sample, but we can use that concentrated pyrrhotite to spike clean samples and create this calibration curve, such that we know when we increase pyrrhotite in a sample, we get these increased peak heights in those drops. And so even though it's not a direct relationship, it's what we call a semi-quantitative relationship between the two, which allows us to know that those magnetic susceptibility drops, which I'll go back to just one more time to reiterate, these drops from the highest point to the lowest point are proportional to how much pyrrhotite is in the sample. So far we've tested, now we're up to 435 homes actually, but this is just as of a couple weeks ago. And this graph shows all the homes that we've tested where magnetic susceptibility loss, that drop value, is on the x-axis and total sulfur is on the y-axis. So, and this is why we do two tests to sort of test each other's tests to make sure that they're doing the same thing. And there's this really good relationship between sulfur and magnetic susceptibility loss. It's not perfect, and that makes sense because there are other sulfur minerals that are in concrete inherently. And that's why even when it's zero magnetic susceptibility, meaning there's zero pyrrhotite in there, there's actually a range of sulfur concentrations that are inherently in aggregate and in mainly the cement portion in the form of gypsum in the sulfur measurement. So, small sulfur amounts could mean that the concrete is pyrrhotite free, but it doesn't always mean that is the case, because as you move in this direction, there are homes that have low sulfur but do test positive for pyrrhotite. And that's, again, really important because you don't want to just use a measurement of sulfur to diagnose a home for having pyrrhotite, because at the low level, it could be misdiagnosed if you're not actually having a test to directly measure how much pyrrhotite is in there. So the color coding of all of these points represent our visual estimation of whether or not there was map cracking at the day we cored that home. We do two cores per home. We established that early on when we got fairly good redundant results from just two cores. We try to get one core that's higher in the foundation if we can, one that's lower, so that if there's any variability between, say, different truckloads for a given home when the foundation was poured, we can see any of that variability. And for the most part, when we collect two cores and measure them, they plot not exactly in the same part of this graph, but pretty close. So a home that has really high pyrrhotite actually is going to be more variable, and the homes that are lower will be pretty closely plot closely together at this lower end of the graph. And the color coding result is our visual estimation of whether or not we saw map cracking at the time of coring. So the red dots are pyrrhotite present, concrete deterioration reported. The orange triangles are pyrrhotite present, no concrete reported. And then the green are no pyrrhotite, zero magnetic susceptibility, or what we deem as a trace level up to 5 magnetic susceptibility loss units. And that number is going to become important in a minute, because this is essentially our cutoff of below which we've never seen a home with map cracking. And I think that's what everyone wants to know at this point. Is there a safe level? And while we don't necessarily know yet if that's safe, based on 430 homes, we can say at least below which a particular level of pyrrhotite is actually potentially going to be map crack free. So, and again, and just to reiterate, the magnetic susceptibility drop is what we are plotting on this x-axis. And so the size of this, or the magnitude of this drop, is directly related to how much pyrrhotite is in the sample. So how much, I mean, magnetic susceptibility loss units don't mean anything to anybody, but we want to be able to essentially convert this to what does that mean for percentage of pyrrhotite by weight in concrete. That's a useful thing that we're going to be able to then be able to report in terms of what does that mean, because again, we're really the only ones doing magnetic susceptibility loss, mainly because I think maybe there's another one at Yale, but Christoph is the only one that actually has this instrument in the state of Connecticut. Rock magnetism is not exactly a really hot topic in earth science, and so these aren't in every single lab across all colleges by any means. So we kind of got lucky with this, in the fact that Christoph has the actual tool that allows us to measure this. But being able to translate what 5 magnetic susceptibility loss means to actually concentration of pyrrhotite is what we're trying to really move towards next. So below this value of 5, we have never seen a home that has had any map cracking. And once you go above 5, the degree of map cracking essentially incrementally increases, and the severity increases as well. And this is somewhat anecdotal. We don't have, if we had hundreds of samples at each of these sort of steps, we might be able to do this even more rigorously. But for the most part, once you have just enough pyrrhotite to start showing signs of cracking, those tend to be fairly light spider cracking, map cracking, not, inch wide cracks that are the ones that are sort of the poster child for the problem and are in an immediate need of being replaced. And so there's this incremental increase in severity and likelihood that cracking is going to occur as you move away from this this threshold value.
Okay, I have a question.
Yeah, please.
Jonathan? Yeah, if we go back to that slide, that green zone, will your report say that there is trace amounts of pyrrhotite?
If we get anything less than or more than 0, if we find the slightest blip of at the predicted temperature to have a little bit of pyrrhotite, then anything above, I mean, once you get to certainly between 1 and 5, we report on our reports that a trace level has been found. And then we define our trace as magnetic susceptibility to this date, everything below 5, and that to date, we have never seen a home where the cores have shown signs of cracking. Now, when you do zoom in, you do see like, okay, there's one that is because there was probably one core that was above this value for that same home. So, it flirted on the line. So one of the cores came back maybe at 9, and then the other one came back at like 5.8 or something. And so we classified both as having a home showing no deterioration, but they would essentially both need to fall below 5 in order for us to give it a green square. So we just err on the side of the worst case scenario, I guess.
Yeah.
For
That green zone seems to be the most problematic for homeowners, because they have no signs or no symptoms of cracking, but they have a document that says, even if it's trace amounts, the document says the concrete has pyrrhotite. And that's something that they have to disclose. And that has run people scared that are trying to buy a home, that now are looking at a document that says you have pyrrhotite.
Correct. And that's not just a problem for those green squares. It's also a problem for every one of these orange diamonds, because every one of these orange diamonds has pyrrhotite, but no concrete deterioration has been reported. And that doesn't mean in the future it won't, because some of those homes might be from 5 years ago that could start showing homes. I agree that this, not just actually down here, I'm more confident every day that goes by, because we've never experienced a home that has had map cracking below that those levels are most likely never going to show a problem. However, I agree that that does not help the public perception of what any amount of pyrrhotite might actually mean towards being able to sell a home. But there are hundreds, if not thousands, more homes that fall into the orange diamond category. And I suspect if we were able to test every single home in New England, there are going to be thousands of homes that will never have an issue that have trace amounts of pyrrhotite in it, just based on the rocks that we have throughout the whole region. So once you start testing for something, you're going to start finding it everywhere. And this gets back to sort of that issue that, where a home along the shoreline came back with a trace amount, and then it was deemed that, that home is now somehow going to start cracking. And, I can't say that, because there's never been a home that actually has cracked at that level. And so, that could change tomorrow if we get a sample that comes in at a magnetic susceptibility value of 1, and it's got cracking all over the place. We didn't want to start saying or putting lines on our graph until we started getting to a statistically significant population of homes that we had tested so far. So I totally agree, though, that it's a problem. But I do feel that we are getting to the point where we're finding a level that could be considered okay. And that's based on statistics.
Is that a 5 number? Is that a percentage? What does that 5 mean? Is it just?
So again, that's the size of this drop.
Okay.
So that
correlate that to a percentage, or?
So I'm gonna go through that sort of those steps right now on how we're going to convert that 5 to a percentage of pyrrhotite.
So what would be the process in coming up with a standard and of what's acceptable, and who would issue that, and how long do you think that would take?
Well, I think we're doing a pretty good job of it right now. As far as the number of data points being able to do this, we're probably closer than anyone else to coming up with this. And I'm going to show you once I calculate what this means for a percentage, how that compares to some other standards that exist, the European standard and the Canadian standard. And you're going to see that they actually fall kind of right in line with those. And those standards aren't necessarily haven't been done scientifically. I think NIST is trying to work on something, but I don't know what they're doing.
That acronym?
The national, the standards.
Okay.
Yeah, NIST.
Okay.
Do you think that value might go up as you do more testing?
So if it goes up, that means you now have homes that have shown map cracking that are now included in that, right? So it's becomes a risk analysis at this point. So if I just go on to the next graph, if you take all the homes that we've looked at and you look at the the presence of map cracking, and you just base it on the amount of pyrrhotite. And we're using for amount of pyrrhotite our magnetic susceptibility loss. And I'll go in a minute, convert that magnetic susceptibility loss to a percentage of pyrrhotite. But using what's called logistic regression, which is a mathematical way to essentially fit all the data we have and ask the question, with the data that you have, is there map cracking, yes or no? What is the predicted probability for any given magnetic susceptibility loss value? And so this is the results. And so, yeah, go ahead.
I apologize. Just for clarity's sake, can you just briefly define map cracking? Is it a specific, just something that's translating to the surface of the concrete?
Yes.
In terms of fine lines or more?
Yeah, I need to pull up a different PowerPoint.
I apologize for that.
No, that's fine. And I wasn't sure, and I have a couple of these ready because I thought I might need to show that as well. So let me.
Kind of in the background that you had as on your screen earlier in the presentation.
Yeah, the white and gray background.
It's cracks that are intersecting, basically.
Like,
Yeah,
Gotcha.
and I think what would be helpful too is just
Like a
showing
map. Yep.
as we go. So as we climb up in magnetic susceptibility values, so if you think again this as a proxy for how much pyrrhotite's in there, this is a low level, and all these homes are about the same age, so like late 90s, early 2000s, so age isn't really being considered, though that's important too. The map cracking, as you go up in magnetic susceptibility, starts to be more severe and larger and more pervasive throughout the home. And then at the highest end, you get, it's all the way through. You can see daylight through concrete in places.
Wow.
And so the distribution of all of our positive pyrrhotite results show that map cracking really increases as you get into those higher levels.
right.
And actually, I have some of the same slides in the back end here, so I'm going to just move ahead here for a second. Right, back to this. So this is our first attempt at trying to predict, based on the data we have to date, whether or not there's map cracking, yes or no. And in this case, it's just the only variable that we're looking at is the measured magnetic susceptibility loss. Again, the greater the loss, the more pyrrhotite is in there. And we start the model at 6 because everything below 6 is 0 anyway. So we fit this model, and you can think of this as for each value that you can find of magnetic susceptibility, what the predicted probability would be that we've tested a home that has map cracking or not. So at let's find an easy number here to pick at 70. So if you had a value of 70 at your home, there's a 50% chance that there's map cracking in that home, which means that there's a 50% chance that you don't have map cracking. And that again could be for a variety of different reasons. You might have a very young house that hasn't shown map cracking yet. So there's more we can do with this in terms of looking at age in order to look at a data set, say from the 80s, that probably if it's cracked by now. Like it's not going to take 75 years for something from the 80s to crack. We'll assume that at least, and we can then compare that to younger homes that might have similar values, and then we can make predictions on whether or not it might actually show cracks.
How much does moisture content in the soil affect this?
It could affect the speed at which the cracking shows itself. So the water and air are the two main components that are going to force the reaction, and you need both. So you don't necessarily want a foundation that is completely saturated with water, because if it is super saturated with water, you can't get any air through there. So humid conditions, which we have both outside and inside homes. I mean, in the summertime, many of us run dehumidifiers in our basements because it's humid down in the basement. There's plenty of water and air in most homes. So while there are things that can certainly speed up reactions, there are conditions that could have been the day that the concrete was poured, for example, the water cement ratio thing can be very important. These are very difficult things to quantify sometimes after the fact. And so there are certainly a host of factors that might that could speed up reactions, could slow down reactions. And so that makes it challenging. So, but we think that probably the most the one variable that is actually going to be the strongest indicator of whether or not and how much cracking occurs is how much pyrrhotite is in the concrete. So it might take a little longer in some houses, it might take be a little faster in others, but at the end, it's the amount of pyrrhotite that's in your concrete that's going to be the most decisive factor on how much cracking and to how severe it might be. So, and now I want to just show you our sort of how we would get from that magnetic susceptibility of 5 to the percentage of pyrrhotite. So if we take all of our data and we fit a line through this, we can use the equation of this line, this y equals mx plus b linear fit of all of this data, to figure out for any given value of x what y would be. So we can plug in 5 magnetic susceptibility loss, and that is equivalent to 0.203% sulfur. Now, again, you can't make, and we can use a value of sulfur to convert to pyrrhotite because we know the chemical formula of pyrrhotite to some degree. But as I mentioned, it's complicated, so it's not perfect. But we also have the problem that clean concrete has quite a bit of variability in sulfur because there are other sulfur minerals in concrete. So we have to somehow subtract those out. And that's challenging because there are a range of values that can occur for clean concrete. So these are all of the samples that we've looked at that are clean, pyrrhotite free, and how much sulfur is in them ranges from 0.08 to 0.2. Though over the last couple of years, it's been fairly consistent that the mean of the percentage of sulfur in clean concrete and the median is 0.14. And this is consistent with some data that we've exchanged with some of our Canadian colleagues who have a lot of data on their sulfur from the issues that they have up there. And this is fairly consistent with when you have normal concrete, pyrrhotite free, you're going to get a mean of 0.014, though there is a range, about 0.1 to 0.2. And this again is why you can't use sulfur alone to determine whether or not you have pyrrhotite. You really need some other means to be able to do it. But we can use this sulfur to figure out, okay, if we know how much sulfur is in there, we also know how much on average is in clean concrete and subtract that out, what the remaining pyrrhotite is, I'm sorry, what the remaining sulfur is part of pyrrhotite. So just bear with me for 1 second here as I walk you through this. The number at the bottom here is the one that we're going to be important. But if we take from our best fit line, the 0.23% sulfur, and then we subtract out our average clean sulfur, 0.14, then the 0.63 is our resulting sulfur that is part of pyrrhotite. And the relationship between sulfur and pyrrhotite is very well known, though there's that chemical formula that's a bit squirrely and the amount of iron can change. For the most part, the percentage weight of pyrrhotite is going to be 2.5 times that of sulfur. And it ranges from about 0.4 to 0.7, depending on those different mineral phases. But on average, about 2.5 times the amount of sulfur is going to be the amount of pyrrhotite. And I'm sorry, PO is just the abbreviation for pyrrhotite. Didn't catch that. And so if we take 0.63, multiply it by 2.5, 0.16% pyrrhotite by weight is our equivalent to a magnetic susceptibility loss of 5. And that's what we would say is in concrete by weight, that's the number that you'd want to be below which such that we have never seen map cracking to date. Okay. I mean, I can't guarantee that it'll never happen, but at least so far for 433 homes, that's the value that we can estimate to best. So what does that number mean and how does that fit in with other standards? Well, the Europeans and the Canadians have some standards that we can kind of work towards what the 0.16 actually is close to. It's a little bit, again, roundabout because they have standards for sulfur in aggregate. So not concrete, and aggregate is a component of concrete, as you know. And so their standard is 1% sulfur is maximum allowed in their aggregate. And that should say in aggregate, not concrete, sorry. Puritites, if purite is found in the aggregate, then that standard drops by 10% to 0.1% maximum sulfur allowed. And since concrete is about 70% aggregate by mass, 70% of the 70% of the 70% of, I hope I'm not showing an older slide that needed to be fixed here. But the end result here is that 0.0175 is what you would extract from the European standard as being how much purite was allowed in the concrete. That number I know is correct. And so our estimate of 0.016 is pretty close to that. And the Canadians have another standard of 0.015. Again, those numbers were not derived from science per se. They were actually court ordered as a admissible level that was allowed to be used for fixing homes and getting funding. And that number has actually changed. But we think this value of 0.016 is pretty close to what is probably quite reasonable for that level of purite that's actually, I guess, what you
with those
consider.
numbers?
What's that?
How did they come up with those numbers that just
So,
happen to be?
The Canadians said that they started with how many homes that they had seen afflicted and figured out what value essentially captured most of the homes such that they could give funding to. And then as that number grew, they had to actually lower that value to essentially allow more homes to get funding to get fixed. But then they lowered it again, but there were still homes that were below that value that actually had problems that didn't qualify for funding, which actually is a problem. But it was not something that was scientifically derived. It was just based on how much money they had and what percentage of homes they were going to be able to fund. So it's a little quirky. So
you mentioned that not all purite is the same. Would that account for some differences in what the Canadians have seen versus what we've seen?
Yeah, it's possible for sure. The rocks in Canada are not exactly the same as the rocks in Connecticut. It's not like it's the same formation that extends all the way up there. It's actually a completely different rock type. And so their mineral assemblage, their ratios of the different phases of purite, their other sulfide minerals that are in their rocks are different. We've also gotten a little lucky with the Connecticut rocks because most of the sulfidic rocks at Becker's Quarry are purite, not other sulfides. And so we can get away with not having to subtract out some of those other sulfides like pyrite, like chalcopyrite, where the Canadians do have to focus on that a little bit because they have higher concentrations of other sulfides within those rocks as well, which makes it even more complicated.
Right.
So.
Very interesting.
Can this 0.16%, can that be picked up through petrographic analysis and compared to your method? Has that been done with the same samples at all?
That's a great question. And I think once you get down to that level, it is very difficult to do it petrographically. It's not impossible for a good petrographer, but when you get down to those really low numbers, the variability becomes really high since you're looking through a microscope and looking at a very small area. To be able to consistently get those kind of numbers is challenging. Now, we have had the ability to compare some of our samples with some petrographers to just sort of compare and contrast. And we've maybe a half dozen samples we've been able to exchange over the last couple of years. And certainly when they find it in high concentrations, we do too. When they find it in low concentrations, we do too. But there have been some cases where they haven't found it and we've found very small amounts. Also, petrographers are usually just reporting the percentage of particles that contain pyrrhotite, right? So their estimations are way higher. They're not trying to calculate by weight per se. Now, if they're doing total sulfur, they can do that. And there's some labs up in Canada that do petrography, and they also do total sulfur, which allows them to get some estimations on percent weight. But petrographers are looking at percent area really of the field that they're looking at and being able to count minerals that are pyrrhotite that are not. And their reports tend to be much higher numbers in terms of what they're reporting because it's a different number. It's the percentage of particles that contain pyrrhotite. The entire particle could be pyrrhotite and be counted the same way as a little fleck of pyrrhotite amongst, encased in some other mineral. And so sometimes, and which is important because the petrographer is also able to see how exposed pyrrhotite might be to water and air, whereas when we don't have that level of visibility of what's happening at the microscopic level. But if you look at petrographers' reports, you'll see like they tend to report things as like 20% of the aggregate we looked at contained pyrrhotite. A homeowner will come to me and say, I have 20% pyrrhotite in my home. And I say, no, you don't. You have to read carefully what it's saying. It's saying that you have 20% of your aggregate contains pyrrhotite. That's not 20% pyrrhotite by weight. If you had 20% pyrrhotite by weight, you'd be sitting on a pyrrhotite mine. So, it's sometimes very difficult to compare those numbers, and it's been a challenge since the beginning. And we try every chance we get when we have homeowners that have done actually both tests to be able to explain that. And it can be challenging to explain it to realtors too, that look at a report and are trying to pick things out of it to make it seem better or worse than it actually is. So.
Are you familiar with the study that UConn has started
I
just
am.
recently?
Yes, they talked about it a little bit at the conference on Sunday.
Okay, how what are they exactly doing?
They are, from what I understand, they have a great way of being able to identify sulfides, which they can tell sulfides from sulfates, and sulfates would be gypsum and some of the other minerals that are not associated with pyrrhotite's a sulfide, something like gypsum's a sulfate, and they can tease out the difference between sulfides and sulfates. But again, I think that's fine at the high level. At the low level, there potentially could be some issues with not being able to determine if something's pyrrhotite or not. And I asked them that directly on Sunday too, and they're using sulfides as a proxy for pyrrhotite, which may or may not work, especially at the low levels.
Mm-hmm. But they're trying to establish an okay standard below a number and not okay above a number.
I guess, but I mean, they also said they have 50 homes that they've looked at now. So I don't,
right.
So yes, I think they're working with NIST as well. They got a grant to work on that. I just don't know exactly how far along they are with that, but yes, they're using a different method to try to do something similar.
Mm-hmm. Okay.
Are you working with the state of Connecticut at all? I mean, they obviously are aware of your work and what you're finding, or have you Where is that? Where do you stand with that, with the state at all?
State in terms of, I mean, I've um,
Well,
which
I would think
department?
the state would be very interested in developing a standard that says
Sure.
you've got below 5% by, or 0.16 by weight, it's not a problem. And are you at a point where, or do they have enough data yet where they feel like they can say that?
We're just beginning to say this, so
Okay.
we're happy to start sharing, explaining what we know. And so we've definitely been in contact with folks in the Department of Housing when we initially got started with this. And the Alina Halloran, who has been involved with the project with the state, she's now in the governor's office, I believe. And we have worked with the state geologist, Margaret Thomas, and showing what we've done. So yeah, we're always happy to share with the state with what data we have. We've shared with CROG, been part of some of the CROG meetings to update what we've learned. And so I've we've been in contact with them as well. So yeah, we're happy to work with anyone who wants to understand what we're doing. And I think we have a lot of homes that we've looked at. I think we've generated enough data now that we can statistically start saying things with some robustness. And in the past, a year or two ago, we might not have, because we only had maybe 100 or 200 homes, and so there were some trends starting to emerge. But you don't want to hang your hat on that. But things are starting to look a little bit more. Things are coming into more clarity now with a larger data set for sure.
Of the 430, have any of those been actual foundations that were under repair rather than taking a core sample, just going there? This was a very advanced foundation and the house is lifted, and just taking that cement and analyzing that with your process. Is that even helpful? Or
I mean, we have tested some homes that eventually did get replaced. We have early on tested a couple of homes as part of our sort of trial study that were getting repaired, and we were able to access some concrete from that. Most of the homes after we started in let's see, around 2018, I believe, is when the captive insurance company changed their rules such that they didn't need to have a core test for the worst case. So those level 3s that inspectors visually were able to identify the map cracking.
Twos and threes.
Right. So there was a point at which we were testing a lot of homes that had the problem that probably didn't need to have a core test. But then when they changed the rules, most of the homes that we tested weren't the worst case scenario, because we would go and be like, you don't need us to core test. You can get an inspector to come for a lot less money to come and tell you you have a level 3, for example, and you don't need a core test. Now that's okay in some cases. I think in the ambiguous level where there have been, cases where there's some cracking that looks suspicious that was classified a 2 or 3 may not have been pyrrhotite. I mean, we've anecdotally found large horizontal cracks that people were convinced that it was the problem that was due to a stick that was stuck in the concrete. And it had no pyrrhotite. And so I do worry that there are some misdiagnosis of homes that do have some levels of cracking that aren't necessarily due to pyrrhotite. And so if it's at all ambiguous, engineers, inspectors really should have it tested, whether we're doing it or whether a petrographer's doing it. It's important to verify that pyrrhotite's the problem in some of the more ambiguous cases for sure.
How did you get into this game? This something you got into? Excuse me, you had the equipment. Is it something because you saw this problem, you thought, well, let's investigate this further, or have you been in the foundation testing business for a while? I
live in Bolton. So I was starting to hear about it through friends and neighbors, because Bolton is one of the towns that has some issues. And a friend of mine, neighbor, said, "Hey, John, you're a geologist. Can you figure out this pyrrhotite problem?" And I said, "Well, we've got some toys at Trinity. We've got some ways of identifying minerals. Let me go talk to my colleagues." And when I talked to Christoph, about it and said, you know anything about pyrrhotite? And he was like, of course I do. It's magnetic. It's one of the easiest things to, it's something we don't really care about in some other of the rock magnetism world, but it's something that's easy to test for. And I was like, oh, well, we might need this instrumentation might be really useful all of a sudden. So we then contacted Tim Heim, who was the sort of lead advocate for the Connecticut Coalition Against Crumbling Basements, and thought he'd be a good person to find out if we could find houses that we could test our method to see if it works. And he was skeptical, totally understandable that, he has a lot of people calling him that say they have the secret sauce. And so I said, well, why don't you give us 10 samples that are unknown? We'll test it for you. And if you know these have the issue or not, we'll test them blind and we'll tell you if it has pyrrhotite or not. And so he gave us 10 samples. A couple of weeks later, we met in his garage and we said, okay, sample A, yes, sample B, no. And we were 10 for 10. And he was impressed and said, okay, let's do 10 more. And we said, great, bring it on. And so we did 10 more blind samples. We were 10 for 10 with those. And then he really thought we had something. And so that's where we started to develop what we do. That's where we started to meet with the folks at the Department of Housing. We met with Commissioner Klein when she was commissioner at the time to explain what we did and wanted to be able to offer this to homeowners as an alternative, fast, rapid test. And explain the differences between petrography and what we do, and that we do some things better, whereas petrographers do other things better, but that we would have another means to test for pyrrhotite, because there was going to clearly be a demand for this as more and more homes needed to get tested or desired to get tested, or in home sales, people wanted to know, and so that's probably been our biggest. Our biggest clients at the moment are folks that are looking to buy a house and they want to know if there's pyrrhotite in there or not. And so.
And are you still the only ones that do the testing this way?
As far as I know.
Wow.
Yep. I mean, I would, I still think it's the best way to know how much pyrrhotite, the best way to split hairs here. Again, we can find it at annoyingly low levels, which, as you mentioned, that can be a problem from a public perception point of view. But the more homes we test, the better we know where the problem really is. And I think we're honing in on that.
Do you know if the reimbursement program is still in process? That was due to sunset.
For testing or for replacement?
Well, for testing, visual testing and core testing.
Right. So that
was through CROG.
Yes. And as far as I know, that's still going on. I do not know when that's due to end. At the moment, we're on CROG's list as a verified vendor for doing testing analysis. And I would hope that if they change their rules around the money, they would let us know, because we advertise that, for our testing services, half of it can be reimbursed up to a certain amount through CROG.
Right.
But yeah, we've partnered with CROG. We've met with them and for some of their meetings. And so, we hope that if things change, they'll let us know.
Yeah. Now you say that a large part of your requests are coming from home buyers that
That's
want
correct.
foundation. Now, are they? You have to get the homeowner's permission.
Oh, yeah.
Are you finding that that's not happening?
Oh, sometimes it's a problem. And we certainly just don't go, fly by night and test homes without homeowners' permissions. Like it's an agreement between the home seller and the home buyer. Last year, there were a lot of homes where, because it was a hot seller's market, home sellers could say, well, you want to test on, I've got 5 buyers behind you that don't care. So, we did not do as much testing, and it wasn't just due to COVID. It was due to the fact that there are homes being bought and sold where, even though visually today it looks good, and the visual inspections come back clean, that it's a roll of the dice, because there'll be some homes that eventually are going to start showing some signs of deterioration. And so,
again, it gets back to that discussion earlier where you have no symptoms
Mhm.
and you want to test my foundation,
Mhm.
I'm going to be reluctant to do that and come up with a report that says I have trace amounts. Because the
Understood.
buyer that wanted this is now, see you later, and I
Not for
have
the
a
trace
document.
amounts. Not for the trace amounts. The trace amounts home buyers have not, they have not told me that they turn their nose up at a home because of a trace amount. They're above a trace amount that don't show deteriorations. There certainly have people have been walking away. But you know, I have not heard of for at least in our cases, and we've got several dozen that have come back at that trace level where the buyer, I'm not saying it 100%, but most people are fine with the trace level because they see that there's never been a problem at that level. And I mean, I tested my friend's home up in Vermont. It came back with a trace level. We test all over New England. We're going to find trace levels of pyrrhotite. And
What's
we
a
need to
trace level?
establish the fact that there is trace levels that are perfectly fine. And there might be higher levels that are extremely low risk. But I mean, me saying it's low risk means nothing unless an insurance company, for example,
Right.
puts their money behind that risk. And that's where it has to, that's how you build confidence back into the market. If there is a insurance company that says, okay, we understand that a particular home is very low risk and it's worth our while to have you guys pay a rider or whatever, such that if something ever were to happen, we would cover it, then homeowners are going to be much more likely to be able to purchase a home that is low risk, because maybe there's only been one house out of 1,000 that's actually shown signs of deterioration at that level. Why wouldn't an insurance company want to sell somebody a product? And from what I've heard talking to insurance guys, it's not worth their effort because this isn't a problem that's big enough on a national scale. And so, you know, but so I can come up with risk assessments. I can come up with probabilities of things happening based on our data, but it doesn't do much good if someone isn't going to put that risk assessment with, you know, their backing and insurance behind it at the moment.
What's the definition of a trace level?
From our point of view,
Yeah.
0.016% pyrrhotite and below.
Right, right.
Oh, okay.
Yeah,
So that's the level. Okay.
yeah.
Okay.
I mean, if that could be somehow official, it would go a long way.
Right. And I agree. And I think, you know, we're only as good as the last data point we measured. And that number, at least so far, has held pretty steady for the last couple of years in the data that we've collected. It's a little scary for us to draw lines in the sand and say that this level is somehow safe. Maybe after 10,000 more samples I test, I could say that. 430 homes, you know, in the high, I mean, it's not bad, but you know, and the fact that risk sort of, it's not like once you cross that threshold, your house is going to crumble and turn, you know, is going to need replacing. So, you know, there are hundreds, thousands of more homes that are just above that level that will never have a problem too. There's just have been one or two that have.
Right.
Have you done any analysis? On that first, one of the early slides, you showed a dispersion of the orange triangles, houses that have higher levels but no problems.
Mm-hmm.
Has there been any analysis done of those orange triangle houses to see whether there's is there a common theme?
Yeah, and I think that would be something that would be great to do. Some of those houses, people scratch their head and don't know why there isn't a problem yet. It could be due to a whole host of a perfect storm of good scenarios around the conditions of a foundation, such that, okay, they don't show signs now, but maybe they will in 200 years. But I mean, what's the lifespan of these homes anyway? So you have to, you know, but there's so many other factors that could be compounding, you know, constructively interfering, destructively interfering to create individual cases. Two houses, homeowners side by side, poured this 2 different days with the same material, could have very different looking results. And it might be because we haven't seen time elapse far enough to know that, okay, homeowner A, his house went 10 years earlier because his conditions are just slightly different than homeowner B. So
a lot of variables.
We're in the middle of some of this, especially for the younger homes.
Yeah.
Yeah.
This is terrific. This is a great presentation. It's wonderful to know that you're out there. I wonder if there's a home inspector association in Connecticut that has meetings. And they might be very interested in this presentation, because if I was a home inspector and I knew you were out there and I had a client, I'd say absolutely go to Jonathan, because he's going to give you much better information than somebody that's going to just take a core test and do a different kind of testing.
I
This
was
is very
thinking, the same-
valuable information.
I was thinking the same thing, Bill.
Um,
That'd be a good thing to do.
Yeah, I mean, this is going to be, this is recorded, Bob, so it'll be on the website, right?
Yes.
So we can alert Kahi to this, and maybe they could come and maybe they do the same thing with you then for that. That would be very helpful. Have you got more, how are you capacity wise? I mean, are you able to do more tests than what you're doing?
Yeah, I mean, at the moment, like I said, things are a little slow because COVID slowed things down, and the housing market kind of affects. Now we've done a lot of Massachusetts too, because Massachusetts is requiring core testing for all of their houses that are I can't remember exactly what they're requiring it for, but they're a little bit more aggressive with making sure homes get core tested if they're suspected of having the problem or part of a sale, or they're in a particular, I can't remember exactly what they're requiring, but they are, there's been some more requests from Massachusetts because they want the visuals to be backed up with a core test, essentially.
Wow, very helpful. Very, very interesting presentation. Thank you.
Yep, absolutely. And I'm more than happy, you can send me to somebody else or pass me along. I talk about this all the time. I'm happy to talk to other folks. I do feel there are a lot of folks out there that could learn a lot more about it too. So I want to make sure that, and we're kind of out there for the buyer in a lot of ways. We don't want people to buy homes that are going to have a problem down the road. And it doesn't mean every home is going to be a problem just because it has purotite too. So,
right. But at least you can tell people that if it's below a certain level, there's a pretty good probability you're not going to have a problem.
Correct.
Which is, as Larry pointed out, that there was a time, or still is a time, when people get a test, it's got purotite, I'm not buying it.
Exactly.
Not necessarily the right analysis.
Right. Right. And we're just learning that, this is fairly new. We're not, we may have said that 6 months ago that we would be more cautious for any home that contained purotite. But I think now that we're starting to see the whole spread of the data, that that's true, that the risk definitely changes as the concentration changes.
Right. Right. Yeah.
So you've done a total of 430 tests?
435 homes. We've done over 1,000 tests on concrete. Because most homes are about 2 cores each, and then we've done other things too. We've done some commercial buildings, we've done a variety of aggregate, we've tested some quarries, so we've done well over 1,000 tests now.
And how many homes are in that bracket below 0.16 roughly?
That's a good question. Because a lot of those clean homes pile on top of one another, it's hard to, I could say the last time I calculated how many homes were clean and trace, it was something about 30% of the homes we tested were on the clean side. And again, remember where we're sampling from is a bit biased, right? We tend to sample from homes that are from these towns that are afflicted.
Certainly.
And every time we get a chance to test something outside of that, it's gravy, because that's another data point. And I almost like it, if you will, when we find trace levels outside of the problem area, because it just enforces the idea that purotite is not unique to Willington, right? It's not unique to one spot. It was in high concentration there, and that's the problem. But we're going to find it in a lot of places throughout New England. So, and that's important because there aren't problems everywhere across New England on this.
Right. Right.
Very good.
Wow, terrific. Anybody else? Any more questions for Jonathan?
Oh, that was a very good presentation.
Really nice.
Thank you.
Really helpful.
Thank you very much, Jonathan.
Yeah,
Helpful.
Absolutely. Anytime, let me know. I'm happy to speak.
We will definitely keep your name and number.
All right.
Thank you.
Sounds good. Appreciate the opportunity.
Thanks, Jonathan.
Yep.
Thanks, Jonathan.
Bye-bye.
Jonathan.
Okay.
I think the main point that we tried to get out of this presentation was there was a belief that if there was any traces at all, then it's a problem. And there definitely is a level that could be safe.
Right.
Well,
It appears
yeah,
to be safe.
we're moving towards that, but homeowners are still reluctant to allow it when it's in the sale process.
Well, that is true, but I think as you see it move forward to a point where, as he says, insurance companies will
Yeah.
insure, and if the state were to come out with a standard,
No,
then
absolutely.
I think it would change the mark a little about whether people say, hey, if I do get it tested, I could be in this bracket
Yeah.
and I'm cleared.
Oh, absolutely. Yeah.
Yeah.
I mean, that's what's needed. And it seems like they're getting there, but
Yeah.
yeah, yeah.
All right,
Okay.
let's get moving here, guys.
Yeah. Yeah.
Yeah, that's the thing, Bill. I'm gonna have to cut out of here pretty soon. I didn't know that presentation would be as long.
Yeah, I didn't know. So let's do a couple things real quick. The DCP investigation complaint status report, we got those from Bob. There were a couple of items. I don't think there's anything really to discuss there, is there?
I don't
No.
see anything.
We talked to Mr. Gorley. The Home Inspector Advisory document went out. That was the thing Larry worked on.
Yep.
The need to get about COVID and about,
Yeah, we got copies of that.
yeah, so you got that. Let me see. Maybe we should go to Cynthia because Cynthia's been patiently sitting here all this time. And I had talked to Cynthia about the problem that we encountered with that case we heard earlier. How do we require supervisors to notify DCP when this relationship between a supervisor and an intern that is not, doesn't have his license yet terminates? They, the intern does 30 inspections. For some reason, they break up. They're no longer associated. We got to know, DCP's got to know that intern no longer has a supervisor. So Cynthia, did you have any thoughts on what our best?
Yeah, so I spoke with Leslie about it yesterday and, our legislative point person. And
Yeah.
It looks like, the statute gives the commissioner the power to promulgate regulations. We know this.
Right.
So putting out like a policy statement, I don't think would be enforceable. It's more like a suggestion,
Yeah.
or it works better when there's already an existing reg or statute and you want to clarify your point.
Yeah.
I think, and Leslie thought that getting together either a statutory change or a regulatory update would be, the most effective way to go about it. Now, that being said, the session is almost over at this point. So,
Yeah, it's a long
yeah.
process.
Yeah, so she said, if we're gonna do this, the language has to be in place by August. So, I don't know if you guys want to put together like a draft or at least the points that you prioritize, or I could start on that. But I think,
Okay.
I think at some point we need to clarify what exactly we're asking for, because, it's one thing to say, report it to DCP. Let's say we put the burden both on the supervisor and the intern,
Right.
as an example. And there is a spot in the regs where we can do that and then just, add it on. But, are we going to completely revoke a permit if someone's no longer working with a supervisor? Or do we give them a grace period to find a new supervisor? Let's say within 30 days you have to.
Yeah, I think, right. I think the answer is that we're not talking about revoking the permit. We're basically saying you can't do any home inspections,
During that time period.
have a new supervisor.
Right. So, but then we have to be clear that the person then has to report their new supervisor.
Right.
You know what I mean?
Correct.
Like,
Yep,
so-
we gotta have a complete circle there, yeah.
exactly, right.
So we have to draft something, I guess, that would contemplate all of those issues.
Exactly. All the possible scenarios to make it. as
Does that
clear.
make sense? I mean, is that something you could take a shot at and then we would?
Yeah.
Okay.
Yeah, I can totally start on that.
That would be great.
Yeah, and I can put together at least, an outline of all the potential, corners that we can try to see around.
Okay,
Then, go from there and see what you guys think of it. And
maybe you can email that out to us. And
yes,
then we can maybe go back and forth before our next meeting and
Right,
Next meeting, we could actually have something to,
right, exactly. We can at least start putting together something from scratch, you know?
okay,
All
well,
right.
that's great. I
Sounds good.
apologize making you sit here for that whole,
I'm a total nerd. I enjoyed that.
oh, did you? Okay, good. Okay, great. Yeah, I thought it was very fascinating.
I
Yeah,
think anybody would. He's
Yeah.
a very good presentator.
he did a very good
Yes.
job.
You did a great job. I miss
Right.
school.
I'd sign up for his class.
No, but it really is. It's kind of nice to focus on,
Yeah,
you really
different
learn
things.
from him. It's really, he was excellent, excellent.
Right.
Well, thank you very much, Cynthia.
Thank
No
you,
problem.
Cynthia.
Yes.
We'll be in touch.
We'll look
Thank you.
forward to hearing from you.
Okay, perfect.
Thanks a lot.
Bye.
Okay, thanks.
Good. Thank you.
All right, so I think that's basically our agenda. Anything else I'm missing here? There's one more thing I want to mention before people have to punch out. So this morning, I get a phone call from David Evans, who used to be our lobbyist I think he is the lobbyist for the monitor for SCAHI. And he's got Representative Horn from Salisbury on the other line. And so she gets on with him. She's got some questions. She's about to go into a meeting and she's trying to bounce some questions off somebody about smoke detectors. So her position is she wants to make sure that we have better smoke detector protection in houses and buildings. And so she's got a couple of questions that she wants to ask about what home inspectors can do more than what they're already doing. So I say, it was like 3 minutes literally. And I said, well, I have some concerns about some of the things she was saying. And so what I suggested to her was, why don't you frame better what your questions are? And then let's get together as a group with her on a Zoom call and just talk about it. So that's kind of where it's very much in the development stages at this point, and we'll see what happens in the future. But I just want to give you a heads up on it.
What
Okay.
does Massachusetts require?
I have no idea.
I believe that's one of the things that they require, working smoke detectors.
Okay. Yeah, I said there were some issues with testing because you push the button and all of a sudden the police department, the fire department show.
Exactly.
Yeah. So I guess we'll discuss it further, but anyway, I just wanted to let you guys know it's something that may happen.
All right. Sounds good.
Keep you in the loop.
Okay.
Is that it? I think we're done. Is that
Okay, I make a motion to adjourn the meeting.
Yeah. I'll second.
all in favor?
All right.
We're out of here.
Okay.
Thanks, guys.
Okay, guys,
Yep.
thank you.
Nice to see you guys.
See you. All
y'all.
right.
Take care.
Larry,
Yeah, bye-bye.